and I'm going to be talking about rethinking state in Angular applications. But before we go there, let me actually then introduce myself. So I'm Alex Okrushko. I'm currently a software engineer at Google at Firebase. I've been part of Google for 7 years now. I'm part of the Nginx team as well, the team that produced all those fantastic state management libraries that many of you are using. I'm part of, organizer of the Angular Toronto meetups, and I'm also part of the group of folks at indepth.dev who produce fantastic articles on Angular, React actually as well, and anything basically JavaScript and web. All right, so that's about me. Not Chris. Sorry for Chris here. All right, so what problem we're trying to solve? Well, as the greatest mind of all time, Albert Einstein famously said, synchronizing state within the application and the backends is one of the most complex tasks that developers have to solve. Well, actually, Albert was here before the internet, so he probably didn't quite say that, but he definitely meant that if he was here with us today. So what is this synchronization of state, and what is this problem that we're trying to synchronize it within the application and the backends? What are we trying to do here? Well, we're trying to do the state management. And before we continue, what is state management? Let's take a look at what is state in general. All right, there are multiple ways to define like what the state is, but what I'd like to typically separate them in two parts. First, we have a server state. So this is your server backend state that houses all the databases and everything else, right? So that's basically our source of truth. And then we have a web app state. And we have multiple states there, such as persistent state, URL state, client state, local UI state, and there are some others, but these are the main ones that we'll take a look today. Okay, so let's take a look at them and understand what those are. This is important because when you're trying to organize your state flows, see how things are transitioning to one to another, where the state lives in your application, you really want to put them at least these 4 different categories. All right, so persistent state. Persistent state is a state that basically you get from the backends. So backends do have, that source of truth, and then every so often you need to fetch some of that data back to your application. So those snapshots of data, those responses that deliver that data with those JSON API calls, that's the persistent state. And we basically push the state to the backend as well. So this is the persistent state that goes to the backend. The next type of state would be a URL state. This is basically what you see in the URL bar. And then sometimes that's also what people mean when they talk about the router state in general. So this is the second very important state. And that state actually drives a lot of our application state. So for example, user enters different URL, that resets the entire application or could reset the entire application. Open other components which do some API calls, which meaning persistent state will get there and all that. So this is URL state. The third state is a client state. For example, which tab is open at this page at the application. So this is a state that's important within the application itself, right? It's very important which tab is open, for example, drives a lot of other decisions. However, this is not something that's persisted to the backend. For example, our database doesn't know which tab is open right now. Our URL knows, but not the database, right? So, and then the final one is a local UI state. So our components, when we componentize our application, we have a common components, for example, such as checkbox or slider here in this case. The slider itself has a state. That state is it on or off, right? The way it interacts with the outside world is usually through inputs and outputs, but within that component, there is an internal state, something that we call a local UI state. So this is the fourth type of state. This is the smallest unit, very independent, right? Very encapsulated within the component. All right, so this is the four states. So synchronizing all of these states in between each other, this is the hardest problem, and probably the most important part of what we're trying to solve as a front-end engineers. All right, so that's great, but we have our tools, right? Angular framework is our tool, and our tool, you know, we are allowed to believe it's very opinionated framework, right? But is it though? Is it an opinionated framework? Well, unlike React, for example, it does provide you with the default forms, default client, HTTP client, default this, default that. So it has a lot of things, CLI and everything else. So it does provide an opinionated way to structure your components, structure your application, and all of that. One thing that's kind of missing in this Angular application is opinionated way to structure the state flows. Yes, Angular provides services, and yes, we know how sometimes to work with them, but that's about it. So let's take a look at some of the problems that we're trying to solve and how libraries like Nginx can help you with that. What I'll take a look here as an example basically has 3 pages, right? So this will be a typical store application. It would have a product list page. It would have a page, you know, once we click on one of the products, we can get the details. And here, this is the page where we can add things to the cart, for example, and you see the cart icon there on top. And finally, once we click on that cart icon, we see this cart page, basically which products we have and how many we added to the page. So we'll just use this toy example, really simple, but we'll see what problems we can run into when building our applications. So let's start with the basic simple component that we have here is the our icon component here, right? This one. So it needs to display how many items we have in our cart. Sounds very simple, right? Let's see the problems that it runs into. Okay, so since we have a state, this is our component. Cart icon component needs to display the count, the number, right? And let me know if my screen is not clear. It should be clear. All right. So it needs to display the count, which is a number. So how do we get that number? How does the component get this 4? Well, there are multiple ways. One of them obviously would be just through input, right? So we can provide it through the input to this component and, you know, pass this data. But then we'll need to have a container component on top of it that basically still talks to some services that get some data. Let's just shortcut this and basically have it in there right away. So we'll inject our cart service, and cart service would have a method to get the cart products, which will return us an array of products and their quantities, right? Product IDs, quantities, which we can, so it returns us an observable, which means we can pipe it and then reduce it to a single number. We'll have a function, for example, reduce cart items to count that we see there, and we'll just, you know, map it and reduce it to the single count, single number. And this is how we get that 4. Great, let's take a look at that service. So here, for example, the service, cart service, that is basically a thin wrapper around HTTP client. So this HTTP client calls the endpoint and gets us an observable back with the cart items, like array of cart items. So this is how we get the data from our service by calling API and basically getting this 4 into this. That's great, but then what we want also notice here is that we are at the page, the cart, you know, cart page. Let's take a look at how this breaks down, because this page also needs the exact same data as well. It also needs to get this cart products. Let's take a look how this page is structured. So we have our cart icon, which is part of our header. That's great. And now at the bottom we have product. We have another product, right? So basically we have a number of products. And then they are all within another component. This is a cart page component. Cart page component itself is within the router outlet, right? And all of it together is in the app. So Our cart icon needs the data, and the cart page needs exactly the same data. Let's take this apart into the tree view and see how we can provide one. So this is our basically component tree, and the way we can provide cart icon and cart page with data without duplicating the calls every time is, well, we can provide it to the top level component in there and then basically trickle that data down through inputs. This is obviously not the best approach. This approach is known as property drilling. It becomes very complicated really fast. For example, header in this case is passing the data and not using it at all, meaning it becomes harder and more, you need more and more data to pass. Putting components in between become hard, components not becoming not reusable at all. So it becomes really complex, really messy, and obviously this is not what we want. What we want instead is have a cart service injected in both of them and provide the data whenever it changes. So cart items here. But how can we do this without duplicating this HTTP calls? Because remember, every time we call the get cart products, it will call the endpoint to give us this observable back. So the way we can do it and avoid this is basically by exposing a reactive property like cart items, and it instead will call this get cart products and will share replay. So share replay is an operator that allows to share the context of this. So that means that only once, once the cart item is called, then everybody else will share this data without extra additional calls. So here at cart items, we have it, and it now becomes a reactive property. Let's see how our component changes. So instead of calling this cart service get products, we'll just pipe off that reactive property. Great, we have that, and it kind of works, right? For now, it works until we start modifying the data. Unfortunately or fortunately, our cart products is not a stale data. It changes. There are multiple ways we can affect that data. For example, we can remove the product. We can purchase all the products. We can remove all the products from our cart. We can add things to our cart. So that data is not stale. It needs to be updated through many actions. So how can we preserve the functionality of our cart icon component where it just listens for the data and does not care how it changes? How can we do this in a way that we just let know the system that we're interested in this data and not be aware what exactly, are we adding things, are we removing things? It just react to it. Well, this is what we're trying to do. And the way to do it is typically what's known as a service with a subject approach. Or somebody calls it reactive service, somebody calls it service with behavior subject. There are basically many ways, or observable service, multiple different names for it. But in a nutshell, it's the same principle. And this principle is that our cart service is no longer stateless, it's stateful. So we have a state that lives within that service. And typically that state is put into the behavior subject. So here we can create the behavior subject of the cart item with initial value of empty array. And we will put it into the private property of cart items subject $. All right, so it's private because we don't want to leak that state outside of the service. For the readers, for the observers of that, we can expose it as an observable. So cart items $, it's a read-only observable. Now, whenever we need to change the data, for example, we're trying to add new item to a cart, what we can do instead, we use this add product as a signal to do something. Notice it returns void, so it doesn't return the observable back. But internally what it does, it calls that HTTP request and subscribes to it immediately. And then when it gets a response back, it will push it to this cart item subject, right? Through this cart item subject up next. So this is how it would update the data. Same for remove all, and all of those. That's great. So now our cart item component can just be listening for that reactive property, and it does not care what exactly is changing. Are the products being added? Are they being removed? Anything else? It just listens for this cart item and reacts to it. And in the constructor, we call this get cart product. And again, notice here, it's no longer returning the observable. It just acts as a signal. So this is the approach that got very popular, and especially for the opponents of any formal state management library, saying, hey, Angular kind of provides us with all we need. We have our service, we have our behavior subject, we love our XJS, and I love our XJS as well, and we can be done with it, we're great. However, what's hidden here are a lot of pitfalls. First of all, the error handling is completely missing, but that's a whole separate item. But the other one that's very, very critical to here is the race conditions. So for example, say user is very excited about the product and wants to add a number of them to the cart. They can click multiple times, and every time they click the add product, notice that it calls the HTTP endpoint. So what could happen is we can have a first click that starts, then the second click goes in. However, the second response comes before the first response. This is a typical race condition, and it happens all the time. Networks are not guaranteed us the sequence of responses, the same sequence as we go there. So this is something that we call incidental complexity, meaning the complexity that we weren't aware of and just hiding within our code. We're not thinking about it explicitly, it just happens to be. This is something that we don't unit test as well, right? So, and then the customer comes back and, hey, what's wrong? There's some issues, and you try to reproduce, you click one, it succeeds, you click another one, no, it works, right? It's very hard to reproduce. So race conditions are those type of errors that are really hard to debug, and again, you really have to think upfront for them to get to them and have them properly working. So one way to control all of these race conditions are effects. And the formal state management libraries like NGRX Store or the newest edition NGRX Component Store really put this problem right up front to you, so you can have these decisions which way you want to handle those race conditions. Okay, let's see how our newest library NGRX Component Store is structured. And by the way, NGRX Component Store is a library of a single file, 300 and change lines of code, and there's another custom operator that's beside it. That's it. So it's very light, super light, and it's very small. It's highly dense with all the goodness for you, performance, and everything else that will go in a second. So Component Store, being a state management library, it needs to do three things and needs to do them well. It needs to read the state. We have a select method for it. It needs to write the state. We have an updater method for it. And it needs to handle those side effects that I just talked about. Let's take a look at the typical example, how we would structure our component store. Well, component store would be replacing our cart service stateful service. So we're getting the cart service back to the stateless, where it was just a thin wrapper around those HTTP clients. The first thing we'll do is define the interface that we work with. For example, this component store will contain the cart items, and it will work with them. Then we'll extend the component store and provide this generic that it will be working with, this cart state. In a constructor, we'll inject everything we need for this component store. For example, here we're injecting the cart service, but again, we're taking this cart service to this original roots, which is just a simple wrapper around HTTP client. That meaning that every time you call the add product or gather product, it gives you the observable back. All right, and then in here we can also initialize this component store with the initial state. So for example, In this case, I'll just have an empty array. We can do it lazily as well, but this is a simpler example. Great, so now what can we do? How can we read things? Well, to read the things, we can select from the store. We can create those selectors. So this select, and then we show how we unwrap things from it, from our state. So for example, the car items observable, we will do the state, we'll process how we extract it. So there'll be a state.car items. That means that anytime the car items will change, we'll get a new, it will emit a new observable back. So car items $ here as an observable of those car items arrays. Great. So then here we can also provide another method, for example, another property, car items count, and this one selects the car items that we just exposed, the selector. And then we'll pass the function how to reduce it to the count itself. Both those selectors are very highly performant. They do a lot of great things inside for the performance. They do a distinct change, they share replace, so they do all those nice things. On top of it, they also track when they need to destroy this service. So they'll unsubscribe from that. Okay, so those are selectors. Let's see how we can use it. So we will inject this cart store the same way we inject the service, and we'll start listening for this cart items count, and that's it, right? So our components stay simple. So updater. So how we update the state. So this is how we read it. How can we update? Well, I can update the state with a special function called updater, and what it returns is the set cart items. And this set cart items is actually a callable property. So you can think of it as a method. Inside, updater will take a callback that describes how can we update our state. So it'll take the current state and the new value that we're passing into it, in this case is cart items, and it will return the new state. So we'll, for example, spread the previous one, and we are replacing the cart items there. So updater takes how we're transitioning, and then every time we call set cart items and we can pass this data into it, it will update the state internally. So for example, there at the bottom you see set cart items and cart items that we pass into it. It will use it and update the state. Another example is set status here, update status with the error. I didn't write this updater, but you get the point, right? You basically pass the value into it and it will update the state. Great, so this is our updater. Now to the fun part, the side effect, handling those side effects. So here's another example. Add product is again the callable function, callable property. You can think of it as a method. And here we say that this is an effect. An effect takes those IDs observable, and those observable is of string or undefined. So this is an observable that it takes. We'll take a second, in a second we'll take a look what it means, this observable IDs, how are they coming from. The next thing it does is those IDs that are incoming, right, those products that we're trying to add, here we have a decision how we can handle those race conditions. And in this case, we'll use a concat map. And what we do is use concat map and ID, and we will call the cart service to add this product. So this is where we are taking things into our own hands, and we can control this. For example, what concat map does is every time somebody calls this add product with a new ID, that ID is pushed into this ID's observable. And then it's passed to this concat map, right? And the first ID it gets, it'll start getting the adding the product. But then the next ID comes in. And what concat map does, it says, hold on a second, this add product is still busy. Until it completes, we wait for it. Once it completes, it will let the new ID in. This is what concat map does. This is a higher order observable RxJS operator. And we can have a choice of other three, so there's a total of 4 of higher order operators. For example, we could have used the exhaust map. And what exhaust map does, it takes the first ID, it starts working, then the second comes in. And what exhaust map does is, hey, I'm busy with this one already, and it just drops the second ID. This is obviously not what we want for adding products, but if we're retrieving data and multiple things are requesting to get the same data, and we're already getting this data, maybe we can drop this in the next request, right? Until we're busy. There's another one, switch map, quite popular actually within the Angular community. Switch map does the opposite from exhaust map. Whenever the new value arrives, it will stop doing whatever it's doing with this adding product and, for example, start the new one. And finally, the fourth one is the merge map. The merge map will start things in parallel. This is what our behavior service with the subject does by default. It starts things in parallel or whenever they arrive. Okay, so here we are choosing how we can handle those race conditions. And here we are choosing to do it with a concat map. All right, so now we call this add product, and it returns an observable. And what we do next? Well, the next thing we'll push it into our state with this updater of set cart items. And should this be an error, by the way, we explicitly want to handle the errors, here I will update the status to error. And then I'll catch this error and map it to the empty, just so our effect does not collapse, because this is still an RxJS observable stream. Actually, this was so frequently that we have to do it and basically catch that error. So there's a new operator that comes out from component store from version 11 that will be about to release in late November, early December, most likely. It's called tap response. It does exactly the same thing that we just saw in the previous slide, but just in smaller lines of code. All right, so this is how we have this effect. And how will we use it? How will we use this effect? So for example, here's the product details component, and we injected our cart store in there. And now we have a method on it, add to cart, and it takes the product ID. Notice it takes a single product ID, right? Straight. And then we call this store, and we call this effect as method, right? Add product and pass this product ID in. See, we're passing a single string to it. But within effect, we're actually dealing with an observable because we want to handle this race conditions, right? We want to be specific which strategy we're choosing to handle that. So every time this add product is called from any place in the application, they are all pushed into this observable stream. All right, so this is what we had. We had cart service with cart items being pushed through it. What we have instead now is a cart store that is provided in root for this case. It's injected into places, and each one is reading the data or pushing the data that it needs to. So this is the behavior subject that we have, the service with the behavior subject on the left that we had before. This is a replacement for it, the cart store that would be handling all of that state for you. All right, so that was how we can replace our services with behavior subject with something that's better suited to handle the race conditions and is actually very performant for all the state management cases. So where else could we use the component store? Well, we just right now saw the provided in root use case. However, we just use the provided in root. But that would be not my favorite approach to the state flow solutions. For example, if we'll have too many services or too many stores, component stores that are provided in root, we're basically, again, flooding our global scope with all of these services that could be injecting other services. So we're getting back into the messy state that we had many services injecting other services and injecting all of them in the components. So that's why I have this exclamation mark. You can do it. but I would be very careful how you do it. For example, if we have a component store that's solely responsible for permissions within the application, yes, it's used everywhere. That would be a great use case for provider and root. But for other cases, there are better solutions that we're going to take a look in a second. So the second one would be complex independent component state. The third one would be reactive local UI state. And last of the use cases that really highlights the component store is those shared component state. And we'll get to all of these three in a second. All right, so provider and root we saw already. Let's take a look at the complex independent component state. So you might see this picture is roughly the same as what we had before. However, instead of the app root, right, card store no longer is provided in root. Instead, it would be provided in a specific node of our app tree. For example, here in the component A. So component A uses card store as a component scope providers. What does it mean? Well, in our component metadata, where we have a selector, template, and styles, we can also specify providers. So our card store is no longer injected in root. It's just a simple injectable. It's provided for this component. So what does it do? Well, what it does is it instantiates this store, card store, for this component specifically, and it also ties the life cycle of our store to the life cycle of our component. That means when the component A is destroyed, for example, we navigate to a different part of the application, the entire card store would be completely cleaned up, unsubscribed, and destroyed with it. That's the great way to manage those, those subscriptions that we always have to add in the NGO and destroy, so we're not leaking state all over. So this is actually a better way to use it with those component scope providers. All right, so reactive local UI state is even simpler. Sometimes we have components that are heavy on the business logic and maybe have some even local UI state that's reactive. For example, in this case, for component B, it could be quite busy. So instead, we can create a specific store just for that component. So it's provided within the component B, so it's still a component scope provider, and it's also injected there. And then we can offload all the business logic from the component into that store. So this is a basically one-to-one relationship, all right? And it's no longer used anywhere else. It could be just for that component. So this is a reactive UI store example. And finally, the shared common component state. This is the state of a component that could be shared anywhere in the application. Sometimes it could be multiple at different places, or sometimes even on the same screen. For example, a very typical case, you have few graphs that you show, on your in your application, and each graph has a lot of complex logic within it. Maybe even does some network requests, but that state is pretty much encapsulated within that common component and all the children that it has within it. So it's not sharing any of that in the application. And this was one of the biggest problems that we had with just any global state management solution like Indirect Store, right? Because our component doesn't need to share that data anywhere outside. It talks to the component that contains it through the inputs and outputs, if it needs even to do the outputs. A lot of times it's just reading the inputs and does some network requests within it. So this was the problem that we were trying to solve. How can we still, because we like this reactivity, we like the performance, we like everything else that comes with the global state management solution. But then this was really an edge case, and this is how Component Store was initially born within Firebase console and then moved to the NGRX library. So for example, here we have another component, also common component, also talks to the A with the inputs outputs. So how we can keep that state manageable and reactive? Well, again, the solution was the component store, because when we use those components called provide, it will be created for each instance of that component. For example, when we have common component 1, it'll have its store, and then component 2 will have its own store as well, and we don't have to do anything. Moreover, the second and third and other children that are beneath that component, if they inject the component store, like common store in this case, they will each get a proper instance from their parent, because this is how the injector hierarchy works in Angular. I know it could be a complicated one, but these are the 4 use cases that really highlight this component store example. So how does it compare with the NGRX store, sometimes referred to just simple NGRX? Well, sometimes we have more things going on in an application. For example, in this page where we see the list of products, we're also trying to get not just the products list, but also the customer ratings that user rated. For example, if I rated the math book to 5 stars, it's highlighted in a different color. The rest of the ratings is just aggregate average ratings from all the users, right? So, but if the user rated one of the products themselves, we want to show them their rating, not the average one. So for that, we have a separate endpoint that we call and get all the products that are rated by this user. So we can think of this product list component as it could have those 2 stores, right? We could have the rating store, it could have a product store. You know, we get the customer ratings from the rating store, we get the products from the product store, and we need to send those signals to get the customer ratings, to get the products. That's what we do in the constructor here. So this is a typical way to do it with the, those component stores. But then if we have more data that needs to be done and more things going on, you see that we'll be injecting more and more things into it. And sometimes it's not the best approach. So when we have an event that we're trying to broadcast to the wider application and let a lot of things know that we are interested in this data, this is where the global NGRX store becomes a little bit more valuable. It scales better as well. Anyhow, in this case, what we can do instead is use the global store, and we can just dispatch the action, the event into the system that, hey, my products page has opened. And then the effects for ratings will see, oh, the products page is open. Let's fetch those ratings. Or and then the product effect says, okay, the product opened, let's fetch those product data as well. And they all fetch the data asynchronously, independently, all push it into a single container, and then we'll do this product store select and just get the view model that we need for this component. So this is where NGRX global store might become more useful, especially if products is the data that's used throughout your application. Okay, yeah, so this is the action. This is the bigger difference. And a general approach how global store works is we have basically a single container of state. This is for the global NGRX store. And then this single container has a reducer, or actually multiple reducers. Each one is responsible for a particular slice of state within the store. Those reducers are acting on those actions. So when there's an action, those reducers can change some of the data, because the store is a mutable source, and reducers are actually just substituting some of the pieces of it. In order to change that, components emit dispatch those actions, and we'll listen to those actions through selectors. But then when we dispatch the action, there's other things they're listening, those effects. They go to the backend, for example, and retrieve the data that turn into new effects, new actions, which can further go into the reducer or other effects. So this is basically how the global store works, all this loop. And if we compare it to the component store, obviously there's something for read, we have those create selectors. For write, we have create reducers. For effects, we have create effects. And then the differences, though, is in an NGRX store, the global one, each of those create selector, create reducer, and create effect. They are completely all independent, separate files. in the NGRX component store, as you saw the example of our card store, they are all basically in a single file. So this is where there's a bigger difference, because NGRX global store can scale basically infinitely. You can create a number of selectors. If you have too much in one file, you can just create a second file and create more selectors in there. While in the component store, if you're trying to push a lot of state into the same component store, your file will start to grow with a lot of updaters and effects and selectors within that file. So you have to be cautious there. And then there's additional selectors that I'm going to touch it. The other difference is in the NGRX global store, the entire state is a single object. There are multiple reducers that are responsible for parts of it, but it's still a single state that we have in our application. When the NGRX component store, on the opposite, we can have multiple of those states. Each can have its own updaters, but we can have multiple of those states. So this is another difference between those two. And finally, NGRX store lives throughout the lifetime of the application, while NGRX component store, it typically attaches to the lifetime of a containing component. Remember when component was providing the store? That means that when that component is gone, the component store is destroyed and cleaned up. So NGRX store basically lives throughout the entire lifetime of the application. All right, so summary. Synchronizing the state is a complex task. There are a lot of hidden things that we sometimes don't realize, and we really have to think about the state flow very much up front. We have a lot of those incidental complexities within the application, something that we can easily miss, those error handlings, those race conditions, and the state management libraries help us to remove those incidental complexities and bring them very upfront for us so we can think how we can handle those conditions. And the last, NGRX now with the global store and the component store basically cover all of the use cases. And for those people who were a little bit proponents or opponents of the NGRX components, NGRX in general, now can replace their behavior services with the subject, services with behavior subjects with those component stores. One other thing, component store internally was initially developed within Firebase at Google, and Kevin Yelko was one of the first people who started working on that. And then when I was bringing it to the open source so the rest of the world could benefit from it as well, Brendan and Tim, my teammates at NGRX open source project, did a lot of back and forth, a lot of feedback, a lot of great input into this as well. Also, huge thanks to the Nicholas Jameson. He is part of the RxJS core team. He helped create one of those custom operators that we use within the component store. And finally, Lars also is part of the, he's part of the in-depth group. He also spent lots of hours with me when we were brainstorming some of the better approaches, how we can handle things within the component store. So those people provided a huge input into the component store, and so that everybody else can use it today. So we have a documentation on the component store. If you haven't checked our website, ngrx.io, guide, a component store should have a lot of information that you can work with. And finally, we have Discords now, both for Angular and NGRX. So discord.gg/Angular will take you to the Angular Discord. It has close to 4,000 people at the moment. Angular team is there, a lot of library authors are there, lots of great discussions, lots of communities. So definitely check that out. And we also have the NGRX one specifically, if you want to, go deeper into one of those packages, the component store or effects, join the conversation there. There's a lot of people helping there as well. So thank you so much. This is pretty much everything I wanted to tell you about the state in Angular. I know it's a complex topic, but hopefully it was useful.
right. Thank you, Alex. Please accept our sincere apology for the mix-up during the introduction.
That's
I
all
know
right.
you. All right. So I know you're very sportive and you're, helping us today. So let me get this right, Alex. Just I'll be let you be the validator for this one, right? So Alex is a software engineer at Google working on Firebase console. He's also a co-member of the Endurex team, a passionate maintainer of the library at Google and an organizer of Angular Tornado meetups.
That's
During his
right.
free time, he writes articles at indep.dev and provides Endurex workshops,
That's
right?
right. Yes.
So that is Alex, my dear friends, who is here today. So let's give him a big round of applause and thanks to him. He's with us today and did a great session on enlightening us today on the rethinking of the state in Angular applications as well. So, my dear friend Alex, you are not yet to go away. So there we have some few questions also for you from our audience, right? So
Yeah,
to
that's great.
conduct the Q&A sessions, we have an interesting individual, my dear friend
Mhm.
Chintana, who will take you through all the questions which the participants has come through. So over to you, Chintana.
Thank
Yeah,
you.
hi Alex, hi everyone. So
Okay.
today we have a couple of questions from the audience. Actually, a little bit long questions, but I will try to summarize the questions and will ask from you. And someone is asking state losses data every time when the page is refresh. So he's asking that he has done some research and kind of things and solve this problem. And he's asking what is the best way to solve this issue. Could you please explain a little bit about the implementation?
Yeah, so it is correct. And when people refresh the page, yes, the state would be, I can't say lost. Yes, it's lost because they will be refetching the data again from the backend, just like it should be doing. Yeah, there are a few ways to handle this. Like, first of all, why people are refreshing the page? Is it because they're getting into this some of the situations where act is already the app is already misbehaving? So if that's the case, maybe you should look at that first. But then, other one is there are sometimes ways that you would want to store some of the data in a very close proximity. For example, in the local storage of the browser. That means that when user opens the page through the meta reducers, you can read that data, and if there is any, and use that temporarily until you actually fetch the real data, the latest data from the backend, so you can have your user to work something with. It all depends how useful it is. And I actually had this talk a few years ago, I think now, in a few places. You can actually see one. There's one from Malaysia and GMI conference. It's called 5 Tips to Improve UX with Endurex. And there I describe this approach through meta reducers, how you can rehydrate the state. Yeah, so you can do it that way. But I'm not a very big proponent for this. Like, it depends what kind of data. Sometimes you want to push that. And for example, even in Firebase console, we do push some of the data into the local storage because it's instantly available for you, right? So yeah.
Okay, cool. I guess hope you understand the answer. Yeah. So we have a next another question from. He's asking. He's using a different kind of state management mechanism. First one is like shared services, reactive store with
Uh-huh.
RxJS, and another one is NGRX.
Yes,
And
it's a
he's
very good
asking,
question.
yeah,
Very good
so he's
question.
asking how we can determine how we can choose the correct one for our application.
Yeah, that's a very good question. So the shared service, the reactive store with RxJS is a service, is a shared service with observable properties. I wouldn't have the first one to begin with, the shared service where you put the data imperatively without reactivity, because it becomes, you're turning that service into something called pool-based service. That means that your components will not know that the data was updated in there until they request it. So if they request, they'll get the data. If they don't request, they don't get the data. So the first one I typically don't even use at all. So the second one, Reactive Store with RxJS, which is a shared service with observable properties. This is what I was showing. This is that service with behavior subject. And this is what the component store is now replacing, all right? So I think this is a very good solution to replace that shared service with observable properties. And then the store like in Nginx is the global store you mean here. So I would typically choose between those two. And the interesting part is that both the component store and the global store solve still kind of unique problems. So it's not you'd be using one or another. In many cases, you'll be using both, but for some situations, you'll be using one, and for some situations, another, and maybe even you could be using a component store and have some selectors that you inject from the global store in there as well. So basically combining the two data streams within component store. So that's also very possible. And this is what we do as well within Firebase console, for example. So how would you choose between which one? So both the component store and global store provide you with this indirection reactive properties, right? So either the store select or a component store, they both have those reactive properties. And this is the indirection where that you listen, those are push-based things that push those data into your components. So you start listening for them with either one. And also when you need some data or you need to notify about something, both component store and the global store, you'll be either calling that effect method or updater method or dispatching the action. So they both use this first level of indirection. Then the global Nginx store would have a second level of indirection. So instead of calling the methods directly, we're having this action indirection, which is basically we need to pass the data through. It basically brings extra cost because you have another second layer of indirection now, but it also brings some benefits, for example, such as scalability and ability to trigger multiple things at the same time with a single action. So it would be up to you as a developer to decide, hey, do you need the second level of indirection or not? Is just notifying a signal directly is good enough? For example, if you are dispatching those actions just for a single effect to be triggered, that means you don't need this, extra layer of action indirection. So this is where you'll see those trade-offs. And also the Nginx.io site, in the component store, I have this comparison between Nginx global store and the component store and which one would be more beneficial. So definitely check that out as well. Hopefully that was helpful for you.
Okay, great. So we have another interesting question. So he's asking that when we use NGRX store, how we can manage the memory in that. And since this is in global store, are there any memory related issues? Have you ever faced something like that?
Yeah, that's a good question. So no, you probably most likely won't run into the memory related issues. For example, again, Firebase console is a huge application, millions of codes, and it works well. There's no real memory problem. You are keeping more in the memory, and sometimes it becomes more of like, why am I keeping some things in the memory when I navigate off that page, and maybe I want that data to be cleaned. And sometimes people even had those cleanup actions that were dispatching on destroy, so that data is cleaned up. So this is what component store gives you for free pretty much, because it will auto clean up everything. sometimes you don't want to clean up. Sometimes you want to have that cache because, when you get back to that page, you may want to reuse some of that information immediately. So those are all the trade-offs, but there's no real memory management issues that I'm aware of. Moreover, with the one thing for sure though, if you are using the DevTools, which probably you should be, make sure that your production version excludes the stored DevTools module. So you're not shipping that, because that can slow down your application, because that one basically snapshots the entire state on each action, because you can, do the time travel debugging or whatever other things you can do. If you probably know what I mean. So just make sure that in production you don't ship that part. All right.
Yeah. Okay. Great. Cool. So one last question, Alex. Actually, he's asking, what are the advantages over Redux and NGRX?
So what are the advantages Redux over NGRX? So Redux is basically a pattern now, really, that NGRX is kind of based upon. NGRX took some things further. For example, effects were created within NGRX itself, but then Redux also created their sagas and things like that. So Redux, you can think of Redux as a pattern now. So it's not one versus another. It's NGRX is built kind of with the Redux in mind, because this is where you have those actions that are basically dispatched, multiple things listening, and everything reacting to it. So yeah, it's not the advantage over. It's basically one is built on top of another.
Okay, great. I think it's pretty much it. I think for the question. Yeah, thank you very much for the delivering valuable session today, Alex. It's really valuable for us and great help for the day-to-day.
I see one more question
very
here.
Much, Alex.
Do you want me to answer one more question? I like it. It's good. What things should we mainly consider when we select the state management library? So the things that you should consider, and again, there are multiple state management libraries, is how maintainable it is, what people are involved with it, are they in it for a long run? Then is this state management library providing you with the best performance and all the recommended practices? Is the state management very well tested? Is it the state management library highly used? And is the community around the state management active as well? So those are all the things that you should consider when you're picking one state management library over another. Thank you.